So, welcome back to yet another problem of this weekly contest 324, and the problem is smallest value after replacing with sum of prime factors. It is a quite interesting problem. You are given a positive integer n. We are continuously replacing n with sum of its prime factors. We want to return the smallest value n will n that we cannot factorize furthermore. So if this is n is equal to 15, we the prime factors for 15 are 5 and 3. So we replace n with the sum of those prime factors, which is nothing but 8. Now for 8, the prime factors are 2, 2, 2, and we replace n with the sum of those prime factors, which is 2 plus 2 plus 2, which is 6. And now my n is 6, and the prime factors for the 6 is 2 and 3. So we replace n with the sum of the prime factors, which is 2 plus 3, which is 5. So for the prime factor for 5 is 5 itself, and it is there is no other prime factors for 5. So that is the smallest value that I can get when I decompose those prime factors. So this is a quite problem if we know how to how to do find the prime factors if for a given n. The time complexity for the solution will be n log n, where uh, each time I'm going to find the prime factors and I'm going to add it to my sum, and I will make the next n. What does that mean is I'm just simulating this problem. So what I'm doing is, if my n is equal to 15, now my next is going to be nothing but the sum of the prime factors of 15. So this prime of n is going, I will be calling this prime of n the function. This function is going to decompose n with their prime factors, and I'm going to return the sum of those prime factors. So I'm starting the factor from 2, and my sum is initialized with 0. So this while loop is going to prime decompose for those n. You can know this function so that it can be useful for finding the prime factors. If my n is greater than or equal to factor multiplied by factor, then if n is divisible by that factor, then n can be divided by that factor, and this factor is going to be added to my sum. Else, if it is not going to be divisible, the else this factor is not divisible for n, then I will be incrementing the factor. And after coming out of this while loop, I will be having another factor, which is nothing but this n itself, because n will be reduced to one to final factor, which we want to add it to our sum as well. If you trace it, you will find it easier, but I will give a dry run for 15 so that it will be easy. My n is going to be 15, and my factor is going to be 2. I am seeing this condition 15 is greater than or equal to 2 into 2, which is 4. So I am going entering inside this while loop, and as you can see that 15 mod with this factor 2 is not divisible. So my I am going to the cells part, and my factor is incremented by 1, which now my factor becomes 3. And as you can see that in this condition, 15 is greater than or equals to 3 into 3, which is 9. So I'm going inside this while loop, and if condition is executed, and it gives me true because 15 is divisible by 3. So I'm adding adding 3 to my sum. Now in my next iteration, my n becomes 15 divided by 3, which is nothing but 5. So as you can see that in my next iteration, 5 is greater than or equal to 3 into 3, which is 9. This condition fails, and I am coming out of this while loop. My sum will be containing 3 now. And after coming out of this while loop, I said before that n is going to be having a prime factor, which will be reduced, that we should add it to our sum as well. So that is what I'm adding this. I'm having in this line sum plus equal to n, which is nothing but 3 plus 5, which is 8. So I'm returning 8. So as you can see that we need that 8 as my next n. So by tracing it out, you can get a clear understanding. It returns me 8 in my for next n. So I have got it in my next. And if my next is equal to n itself, that is, this is the base condition. If I am not if I cannot prime decompose it to some other number, I will break out of this loop and come, and I will be saying next is my n. So, and I'm returning the last n, that is the smallest value that I can get, and this also gets accepted, and I will just run and show. And yeah, that's it for this video, and hope you understand this problem, and I will suggest you to solve by yourself. If you do not know this prime factorization, it will be unhelpful and it will be a good learning to know it at least now, at least by now. So this is it for this video. Let us see in the next weekly contest problem. Until then, bye.